Well, hello there. I was just about to eat some delicious and nutritious salad. All I need now is some salad dressing. Oh, my favorite. Whoa, what's wrong with my salad dressing?
Hello, Mr. Ritz.
Whoa, hello, Jason. What's up?
Well, I thought I'd call to let you know there is nothing wrong with your salad dressing.
You're reading my mind again. Why is my salad all clumpy down here and all clear up here?
That's a good question. That has to do with the different densities in the liquids of your salad dressing.
Different densities? I'm not quite sure what you mean.
No worries, let me show you. Have you ever wanted to make your drawings come to life? No, I mean actually move. Yeah, so have I. Welcome to Impossible Science. Hey everyone, it's Jason Latimer, the world champion of magic. Now today's topic, drawings that animate on their own. Now, what you just saw with that dry erase board, well, that's obviously an illusion. But today I'm gonna show you an experiment where your drawing will come to life and it uses one of these. That's right, a dry erase marker. So grab one of these and I'll meet you in the kitchen. Wait, a drawing that can actually move? Yeah, pretty cool, right? Now, before I can get into how to do that, I want to go over this little science experiment with you. See, you can do this at home. Take some oil, take some water, and if you pour them in a glass, they'll separate themselves. Now, anybody who's ever mixed oil and water knows they will never mix up because they have different chemical bonds. But what I wanted to show you is that the oil will always sit on top of the water because they have different densities. See, oil is less dense than water. Oh, wait, what's density? Let me explain. Density is the relationship between an object's mass and its volume. Mass is the amount of matter or substance that makes up an object, while volume refers to the amount of space an object takes up. In other words, density is how heavy something is for its size. Imagine a scale with a block of water on one side and the same size block of wood on the other. Given the same volume, the water is heavier for its size and it will tip the scale. The block of wood is less dense than water, so it would sit on top, which is why wood floats on water. If we swap out that block of wood for the same size block of metal, we can see that the metal is heavier, so we can see why the water would be on top. The metal block is more dense than water, so it would sit on the bottom. If an object floats, it's because it's less dense than the fluid it's sitting on. And if an object sinks, it's because it's more dense than the fluid it was put into. Okay, so now we know why oil was sitting on top of water. It was less dense than the water. And why is that important? Because dry erase markers have two major ingredients. The first is alcohol, that's used to dry out the ink. The second is the releasing agent, that allows the ink to be rubbed off. That releasing agent is made of silicone oils. Wait, did you say oils? Yes, the same oils that sit on top of water. Check this out. If you take a dry erase marker and you draw a figure, we let it dry first. The alcohol evaporates and now we have only the silicone oils. We take some water and we carefully pour it into this tray. See if I can get him to go. There he goes. Woohoo! It's party time! Pretty cool, right? I can even get him to tilt. Whoa, whoa, whoa. Oh, I could make a surfer. All right, I'll show you some cool things you can do with it. Now, you want to draw on a smooth glass surface, something that's not porous. And you can be super creative. You can have different colors, you can have different drawings, but the thinner the lines, the harder it is to keep the picture together when it comes off the bottom. Okay, now that we know how to make drawings come off the surface, you can actually transfer the surface. Let me explain. Draw it in a small bowl and then lower it into a tub of more water. Do it slowly, try not to break the image. Now, once you have that image floating around on the surface, you can put it on your skin. Watch. It's so cool. Well, that's it for today. I hope you enjoyed making a drawing move on its own. And until next time, stay curious, because the right question changes everything.
Wow, That was awesome sauce! Did you observe how the oil and water were separated in Jason's glass? It looked just like my salad dressing, don't you think? I wonder what would happen if I shake this up. Look at that! It's all mixed up and ready to dress my salad. Delicioso. Right now, the salad dressing is all mixed up. Do you think it will stay that way? Let's investigate. We'll come back and check on it later. I wonder, do other liquids have different densities? What else could we try? I'll be right back. Look what I found. Honey, syrup, dish soap, milk, vinegar, and vegetable oil, and a jar to put them in. Let's investigate with an experiment. I'm going to add these liquids to this jar, one by one. I predict that some of these liquids will have different densities. Big word alert. Predict means what you think might happen in the future. What do you predict will happen with these liquids? This is honey. This is syrup. Ooh, hello, syrup. This is dish soap. This is milk. Wow, look at the milk. It's going under the dish soap. This is vegetable oil. Oh my. Now the dish soap is going in the middle. Remember, students, pour slowly if something is heavy and use both hands. This is vinegar. Wow, look what's happening. The liquids want to separate. Do you think that's happened to my salad dressing too? That's right, it did. Take a look at it now. Can you see all the layers? I wonder if Jason has any other lessons for us today.
Have you ever wanted to see an object transform its own shape? Yeah, me too. Welcome to Impossible Science. Hey guys, Jason Latimer, the world champion of magic, coming to you with another Impossible Science. Now, today's topic, can we get an object to transform its own shape? And what you saw earlier in the show, well, that is obviously an illusion. But that doesn't mean we can't make it happen through science. In fact, today I'm going to show you an experiment that you can do on your side of the screen to make an object move on its own and change its shape. And it uses these. That's right, tiny, tiny chopsticks. Just kidding, they're toothpicks. Grab a handful of toothpicks and some water and I'll meet you at a table surface. Wait, objects that actually move on their own? Sounds a little creepy, but totally cool. See, I'm gonna show you a little experiment that you can do at home, but before we get to that, I'm gonna do a little bit of magic through the screen. I have 3 different shapes here. I've got a triangle, I've got this red pinwheel, and I've got this purple square. Now, in a moment, I'm gonna ask you to pick one of these 3 by putting your finger over that shape on your side of the screen. So let's say you're here. I'm gonna ask you to make some moves. So if I said make 2 moves, you can go 1, 2, or you can go 1, 2. You can go left or right with those moves, but you're only allowed to move 1 move per step. So you just can't jump. Make sense? So put your finger over your favorite shape right now. Just put your finger over it. Now, I'm gonna add 2 shapes to the mix. Again, you can move left or right, but you can't jump. So I want you to move 5 times. Ready? Go. 1, 2, 3, 4, 5. Keep your finger right where it is. And I don't think you're here. And I don't think you're here. All right, keeping your finger right where it is, I want you to move 3 times. Ready? Go. 1, 2, 3. I think you were trying to trick me on that one. I don't think you're here. I need you to move your finger one time, so move to the opposite shape. Go. All right, now in the bottom of the screen has always been a prediction that's underneath this postcard. And I've made it out of toothpicks myself. Keep your finger on your shape. I'm going to say, my prediction is the pinwheel. Did I get it right? No? That's okay. Today's episode is about an object that can change its shape. So think of the shape that you had your finger on last. You got it in your mind? I'll just add some water. Watch what happens. Concentrate on your shape. It's alive! Look at it go! I'm guessing you selected the star. So how's it working? Well, each of the toothpicks I've put a little motor. No, I'm just kidding. There's actually a thing called capillary action going on right now.
Capillaries are tiny hollow tubes within plants, trees, or even the wood in these toothpicks. Capillary action is how plants get water to move up against gravity from their roots to their branches. Water is attracted to the sides of these tiny straw-like capillaries, but water is also attracted to like molecules of water. When a liquid's attraction to a different material, known as adhesion, if that outweighs its attraction to like molecules, or cohesion, then the liquid will climb the surface of that different material and it will pull like molecules along with it. The flow of this liquid along a surface or through a surface, even if it's against gravity, is known as capillary action. The capillaries in this wood of our toothpicks are swelling up with water as it climbs through them, pulling in even more water. And as the fibers in the capillaries swell, they're straightening out the bends which we made, which makes them move on their own.
All right, so now that we know what capillary action is, let's put it to use. Let me show you how to set up this experiment. You're gonna need 5 toothpicks. They don't have to be the colored toothpicks. You can actually use any ones. The thicker the toothpick, the better. And what we're gonna do is we're gonna bend them. We're gonna try not to break them in half, but they're gonna bend like that. And we're gonna do it for all 5. Now, we're gonna put them in this arrangement with the bend parts towards the center. And if they don't line up, that's okay, just bend them even more. And that's it. That's the shape right there. All the bends into the center with 5 different toothpicks. And all you have to do is just add water. By adding a little bit of droplets of the water in the center, what's happening is the wood, through that capillary action, starts absorbing the water. This absorption of water causes the wood to expand as it swells up. That swelling up straightens out those fibers and causes these toothpicks to move. Now you could just do this on a table and make it look like you have superpowers. Isn't that great? It moves on its own. Well, try it out and see how it works out. And until next time, stay curious, because the right question changes everything. Oh, it just jumped out. Gets up, it just runs away.
Wow, that is so cool. It reminds me of one of my favorite experiments that demonstrates capillary action. Big word alert. We know that plants, including cut flowers, drink water. What do you think would happen if we changed the color of the water? Do you think capillary action would draw the dye in the water into the plants? Let's investigate. Here, I've got some plain white carnations and jars of water to put them in. I'm going to add some food coloring into the water and then we'll wait. What do you predict will happen? Here is some blue dye. Here is some red dye. Here is some green dye. Let's check in on them in a little bit. Today, we're going to draw our friend, Sammy the shark, and then we're going to go for a swim. For this directed drawing, you can follow along using a whiteboard, a clear dish, and dry erase markers. Or you can simply use a piece of paper and something to draw with. That's fine too. You might even like to use a pencil so you can erase. Let me get my glasses on. First, I'll draw an outline. Here's the ocean bottom. Over here will be the pier. Remember, Sammy loved swimming by the pier. Now, I'll add in the water with some waves. I'll make a beautiful sun in the sky and only one little cloud. I'll add some fish in the water, some small fish. Hello, small fish. I remember there was an octopus. Maybe I'll make a lobster. I'll add some seashells. Maybe a starfish. Another starfish. And now I'll color things in. I'll use 2 different kinds of blue. One for the water. I'll add in some barnacles. We learned all about barnacles from Sammy. I'll make a beautiful pigeon named Patty. I'll add in the yellow for the sun. I'm going to put some sand on the bottom of the ocean. So I'm coloring it brown. I'll darken in the pier. Look, we'll color in Patty. She's a combination of blue and black because she's kind of gray. And I remember she has 3 little toes like a claw. I'll color in the octopus and make him pink. I'll have a pink seashell, maybe a yellow starfish. Ooh, I'd like a nice red lobster. A couple of goldfish. Wow, look at all those beautiful colors. I'll add a little bit of blue to the sky. I think that's a beautiful drawing. Now, what are we missing? I know, Sammy the shark. Let's start drawing Sammy. We'll take out the dish just like Jason. I'll put the dish right on top. I'll take my dry erase marker and I'm gonna put Sammy right in the middle. There he is, he's swimming. He's a big red shark. Let's let Sammy dry. I've never seen a dry shark before. Now we'll add in the water extra slowly. And we'll go right by Sammy. I see Sammy, he's starting to lift up. He's starting to lift up. I'll add a little more water all around his body. And I think Sammy is ready for a swim. 1, 2, 3. Swim, Sammy, swim! Look at Sammy go, he's swimming in the ocean. Ooh, Sammy, stay in the water. Don't eat that lobster. Boy, he's swimming everywhere. Look at Sammy go. He's just swimming from side to side. Look at Sammy come to life, just like Jason taught us. Because the dry erase markers contain oil, the water won't dissolve it. Instead, Sammy got to float and swim. What do you think happened with our flowers? Do you think capillary action helped them change color? Let's go take a look. Wow, look at that. They've taken on the color of the water. You can try this at home with carnations, a glass of water, and some food coloring. Be sure to have a parent or guardian help you. We learned so much today. We met the world champion of magic, Jason Latimer, and learned that oil and water do not mix. We learned that dry erase marker is made of oil, and we can make drawings come to life. We learned capillary action helps trees and plants absorb and transport water through their roots, branches, and leaves. And we learned that we can use capillary action to color flowers. I had so much fun exploring science with you today. I'll see you next time. Bye-bye.